Welcome everyone to today's webinar. I'm Daniel. I have the honor to be your presenter and host of this session. And today we would love to talk about agentic AI and automation trends in engineering. And especially we want to look back what happened in 2025 and make a wrap up, and also use the time to talk about what's coming next. What are the big next things that we will see in 2026? I'm super thrilled that I'm not alone today. I have two experts in this field of agentic AI with me. The first is Dirk. Dirk is one of the leading experts at Accenture in this context. And I'm, super thrilled to have you here, Dirk.
Yes, thank you, Daniel. I'm also very excited and looking forward to this discussion. I can already see that we are 65 participants here in this round. So I'm looking forward for insightful discussions with you, and I'm very happy to be here.
Great. Thanks, Dirk. And last but not least, we also have our head of AI from Synera with us, Ram.
Thanks a lot, Daniel. Yeah, always a pleasure to be in this way to engage with our customers and also share our learnings and also the thankful for the opportunity that we are able to talk more in such round about the problem space and the solution space with Dirk.
Cool. Yeah, normally I also get invited as experts normally, but today I have two experts, so it's even better for me to have the real experts here in the room. So super, super happy to have you here. Some organizational topics. Dirk already mentioned it. We want to make it as engageful as possible. So that means whenever you have questions or things, feel free, please, to use the chat function or the FNA function out of Zoom. And we have a dedicated FAQ session at the end of this presentation. And we also want to use this time to really engage with the audience and make sure that we are also carrying all the topics here. Okay, with this being said, are you guys ready? Shall we kick it off?
Definitely. Maybe one hint from my side, there's already a risen hand in the chat,
Oh,
Daniel.
okay, let's see. Good point. Uh, but I think that at least there's not a chat message yet. Maybe that was just more like a
Okay,
emoji or a reaction. So whenever you want to interact with us, please use the chat or the FAQ session. This is the best way to yeah interact with us, and then we will make sure that your content will be shared here. Good. So let's get started. So today we have two main topics. So the first is we will look back into the year 2025, and Dirk and Ram will share their experience, what they have learned in 2025. And then for sure, we also want to be prepared for the future, especially in a topic like agentic AI, where everything is changing so fast. So we will have another big section today, which is preparing for 2026. And also here, we sit together the last couple of days and thought about, okay, what are our biggest bets for 2026? And I can tell you, it was a very interesting discussion among these experts. But at the end, we made our decision. So super thrilled to share also these results. And for sure, we want to make a quick recap and also wrap up of the session. Okay. To make it a little bit more interactive, we would like to also get involvement from you guys. And maybe you already recognize this question. So this is a time where you either grab your phone and scan the QR code and get engaged with this little survey here, or we will also share the survey in the chat in a second. So where you can then click, in the chat. And the question here is, we would love to know from you before we start, how familiar are you with AI agents and their potential benefits for especially engineering work? So let's wait one more minute before we then continue to see that everyone can put responses in. And I see, oh yeah, the counter goes up. So let's see. Any guesses already from Dirk or Ram about the distribution of the results?
I think it will somehow be normal distributed. So a lot of people will already have their touch points with Gen AI, but I doubt that there will be many that are very familiar.
I would say so. I
Okay,
think when we started this topic last year, we saw a little bit less awareness, but this has been changing a lot. So I would also put it a bit more that everybody is knowing what an agent means.
good point. So I also did my homework here for this slide and checked the results from last presentation and last webinar. And last time we had 40% who were completely new or have very limited knowledge to AI agents in engineering. So it's really interesting to see that we also have a lot of new joiners, at least last year. So let's see what happened in this year. So let me show the results. It's, I
Wow.
would say, less than 40% now with the new joiners, but we have the biggest group here is somewhat familiar. So either have already heard from this technology or I use it a bit. So I think this is also the perfect audience then for us today to not work on all the basics, but also talk about the things that really matters. Okay, so let's get started with a look back at 2025. And before we deep dive into the technical things that change, I mean, we're doing it all for a purpose, right? And in engineering, the biggest purpose that we see among all our clients are mainly in these three big chapters. So one is we see a lot of talent shortage in industries. So, and also the demographic change will also increase this heavily. So what can we do to overcome this talent shortage? And for sure, one strategy could be work with digital coworkers. The second one is productivity pressure. In a lot of different industries, especially, for example, automotive and also in the Europe region, we see a lot of pressure here to be competitive and stay competitive. And we need to go new ways to achieve these goals. And last but not least, I think every company feels this expertise bottlenecks, especially in engineering. So when you enter a new company and you want to solve something, and then you have to ask the colleagues, okay, who is the expert? And at the end, there are two or three maybe in this organization. And yeah, they have a huge backlog normally. So how can we overcome this hurdle? So these are the biggest challenge that we see. For sure, there are many more, but if we cluster them, then you see that especially the technology that we are talking about will give you an impact on these three large problem statements. Okay, as we still have some new joiners, a quick, really, really short recap. What is an AI agent, right? So you can think about of an AI agent like a digital coworker that you give a task, and then this bot or agent is doing something for you and give you a response, and then you can keep continuing the conversation with this assistant. And to build your own agent, you normally need three different ingredients. The first one is you can think of the brain. It's a large language model, so it comes with a lot of pre-knowledge from the general public domain. Second one is the specific context from your company, but also the memory. So everything what the agent has learned over time or what the agent knows from your company will be in this context layer. And because we not just want to chat with these agents, we also want that these agents are working for us. We need to provide them a tool layer so that they can perform actions inside of software and in engineering specific software like CAX technology, either in CAD or simulation or in all the adjacent technologies. And what we already learned is similar to how we as humans are organized is the best way if you're then dealing with agents is not to have one agent, but more like a group or even a whole department of agent, where you give every agent a specific set of these three ingredients, like a specific model with a specific access to this memory and context, and also a specific subset of tool access. And then you team them up in a department, and now you're giving the task not just to one single agent, but to multiple agents. And this was already available as we started into 2025. And in the next couple of slides, we want to show you how this whole systems evolved and what also the industry is already doing with these kind of technology. And to now really deep dive into this topic, I'm super thrilled to hand over to Dirk, who will give us some insight about how Agentic AI evolved as a solution. Dirk, over to you.
Yes, thank you, Daniel. So you've already mentioned that there are many engineering challenges coming up, and I would like to focus or spend 1 minute on all the challenges we are seeing at our clients. So here, as you can see, you see the V model. So basically how product development is currently conducted within organizations. And now, when we talk to our clients, when we work with them, there are several challenges coming up. First one is data silos. So there's a lot of fragmentation within the organizations, and data from one engineering domain remains in that domain. Then the second challenge is complexity, especially with different disciplines such as mechanics, electronics, electrics, and also embedding software in very complex systems. The complexity rises and rises. Then what we also see are late and error-prone integrations. So when we have errors occurring in the product development process, they are identified very, very late, which is, of course, very cost and resource intensive. And in the end, that leads to very long development cycles. And especially when we take a look at Chinese competitors, they are developing their systems a lot faster. But on the other hand, there has been a lot of research conducted in the last 2 years. So I think ChatGPT came up in 2022. And in 2023, we all have experimented with ChatGPT. And now new technologies have come up in 2024 and especially last year, which you can see now on the right side of the slide. And these things can tackle the problems at the left side. So first field where a lot of research has been conducted is agentic orchestration. So now with multi-agent systems in particular, we are able to decompose very complex development tasks into subtasks, which then can be managed by multi-agents. Then the second thing is context management. So especially in engineering, we are dealing with a lot of domain-specific data. And what we can now achieve with context management, especially RAG and knowledge graph solutions, is that we can make our engineering data machine readable and provide context to multi-agent systems, which makes it very, very beneficial to complete engineering tasks. Then what came up in 2025 is the capability of reasoning. So now the models really learned to think. So if you just give an abstract goal or an abstract task to an LLM, the LLM can decompose it and can really make or can really think about how to solve the specific problem. And then the last capability, which is very, very exciting, is tool interoperability. I think MCP servers came up in the end of 2024. And we've in the last year experimented very much with MCP servers. So now we have solutions which can really make tools, engineering tools, such as CAD tools or simulation tools. They are accessible for multi-agent systems. And this is a capability which is very exciting and which opens the room for new use cases in engineering, I would say. So what I would like to present today is the concept of vertical and horizontal integration in systems engineering. You can see here on the left side of the slide a very simplified way of how artifacts are being created in the whole product development process. So on the top left, we start with requirements, with unstructured requirements, and they are in the requirement domain then enriched and detailed to customer requirement specifications, and then in the end, a whole requirement model is created. And this detailing of artifacts in one single domain is what we call vertical integration. Horizontal integration is when we step over from one engineering domain to another. So if we move from the left to the right, so we're starting with requirements, like requirement models, and then based on that, we generate a system architecture, a functional architecture, or a logical architecture. And these concepts of vertical and horizontal integration, they are really important to what I would like to present on the next slide, because what we have done is we had a research collaboration with DFKI, so the German Association for Artificial Intelligence, and with Fraunhofer. And within that research collaboration, we have read a lot of scientific publications in some 137 studies in the engineering domain. And we have analyzed whether the use cases described in these publications are more vertically or horizontally integrated. And this is basically the result of this study. So you see here on the y-axis, the maturity of vertical integration, and on the x-axis, the maturity of horizontal integration. And what we can see here that most papers have a higher vertical maturity level than horizontal maturity level. So they focus on very domain-specific tasks and are not able to connect engineering domains or engineering data across tools or across engineering departments. And based on that, we derived two central findings. The first one I already introduced. So most of these publications have a higher vertical dominance. And the reason for that is that the AI applications within enterprises as well as in the scientific environment, they are based on fragmented tools and data. So whenever a problem occurs within requirement management or within product design, someone like the responsible of this department will come up with a Gen AI solution and tackles one very domain-specific problem. And our recommendation is to overcome this vertical dominance of Gen AI use cases by opening up the solution space. So AI application landscape should be centrally managed, and we should focus more on horizontal applications where data and tools are connected to each other, and the different domains are also connected to each other. Then the second finding we could see here, when we are looking at the top right corner of this plot, there are a lot of publications that have a high vertical as well as horizontal maturity level. And we could see that all these publications apply multi-agent systems. So when we want to achieve a very high vertical and horizontal maturity level, we should apply multi-agent systems because they can connect different data and they can be applied across different tools, which accelerates the product development way faster than traditional Gen AI applications. And here the central prerequisites for these applications are, first of all, of course, tool interoperability. So making the tools accessible for the multi-agent systems. We have to provide context across multiple levels, across multiple tools. And we also have to connect data, processes, and tools on a higher level, which is why we recommend to timely establish these central prerequisites in order to execute very high valued proof of concepts here. With that, I would hand over back to Daniel.
Yes, Dirk, thank you so much. It seems that 2025 was a busy year in research and evolving technologies. Also, very interesting to see that you came to a very similar conclusion that the horizontal scaling, especially due to multi-agent systems, seems to have the biggest impact shown in 2025 for accelerating product development. And I think Ram can give us some more insights about how this technology is also applied at customers already and what we learned from Synera perspective. Ram, over to you.
Yeah, thanks a lot, Daniel. And also thanks to you, Dirk, for giving such a nice data-driven assessment of the current landscape. And that is also what I want to touch upon a little, but quickly pivot to practicality. So the way we see it in Synera is we work on agentic systems and they are determined by three factors: quality of model, the quality of context, and the quality of tool. I think Dirk touched upon different things that matured over 2025. And in our round, the three of us asked, what is the best way to show how this all came together and it really worked? And since we are also a bit of a software fan, the best proof point that this formula or this understanding of technology works is how the software industry kind of got transitioned into a new paradigm of working. So it's called now Software 3.0. And that is if you have a good model, if you have good context, and you have good tooling to code, much of it can be highly automated. And this is a good proof point that this formula can also work in our domain. But now we wanted to see how many people applied it, what happened. And that is what we did. So we want to present to you what we call the implementation chasm. So in 2025, a lot of teams across the world started to deploy agents into everyday use. We also did it at Synera. So we built 20 plus enterprise grade engineering multi-agent systems. We got our learnings, but we wanted to see, are our learnings same what the world learned? So we found also this really nice study which covered practical applications of multi-agent system. And we wanted to overlap and see what are the findings, what can we share here. And one point to start with is that 2025 already revealed that technology is not anymore the barrier, but it's reliability of these systems. So now going into what the actual results were. So what use case? The biggest, I think, question that most of us have when we look at a new technology is, okay, where should I apply it? And also from our findings, but also from these 100 plus systems that were developed, the top drivers are interestingly productivity related. So it's how do we take away the repetitive tasks from human? How can we, routine automate the labor that we are doing again and again? And that was revealed to be still the, let's say, the most impactful application of agents. And also in the next slide, we will see why this is important. Because when companies started with this new technology, they wanted to see a tangible benefit, right? So they wanted to see how can this technology help me today, and not so much on the innovation side. And this is what we saw in 2025. So companies were very interested in linkable business objective, not so much in the agent architecture, but what is the use case for me? And that's why we say novel technology is only maybe 33%, but we see increasing productivity was on a higher range of use cases. And this is also important when we talk about enterprise. We need to make sure that agents, even though they have a non-deterministic component, they need to be tolerable and reversible. And so how mature are these systems? Again, I think we can all agree that it is not a research question. It was not a research question in 2025. It was a more practical application. So almost half of the systems, also in our experience that we built, are already into production. So they are production ready. It's going to be used by hundreds or tens and hundreds of engineers. So the whole space around this agent kind of crossed in 2025. Can this work to how do I run it safely? So I think that was the important revelation in 2025. And again, the reason most of these go into this production where you can link business value is because they are mostly internal tools or expert knowledge driven copilot. So everybody wants this knowledge, and experts are almost always under pressure in any organization. So this made sure that the use case and a combination of all the practical tools available, we see more and more things going into either pilot or production and not so much anymore in the prototype. And also very interesting finding, even in Synera, we have these different layers of automation. So we have a tool, but we also have context, but we also have large language models. So when we see, okay, what is an alternative system to the agents that we built? The question was, what is usually done if there is no solution like this? So the alternatives are typically, it's either manual work, there are maybe some scripts lying around, but they are kind of shattered here and there, or it's normal automation tool. And the interesting, let's say, finding was that when you try to pick up this existing automation and you link it with agents, the flexibility and the overall orchestration adds a new value. And whenever there was no existing solution, this is because organizations thought there is no alternative. So there is this novelty element yet. And we see this also, right? For example, extracting 2D drawings. The original way would have been a human sees it or some other way, but we see a lot of shift happening in this domain. And that is the net new capability. So instead of building automation, why not use a multimodal model to do these new tasks? But what we also got to know, which is also in our understanding, is most AI agent systems are today still text first. So we rely a lot on text. I think the shift is happening to more and more images, but we also see the different data types that models are being worked upon. So all the logs, text, tabular data, it's almost already supported now. But interesting for maybe the audience here is kind of seeing where is the deepest desire. So it's probably in scientific data, images, or even this kind of spatial images, right? So we want more and more 3D understanding. And for us as engineers, we need structured data, not just some text, but we need tables, we need something that's readable. So multimodality as a research topic, 2025 proved that it's not anymore nice to have, but you need to have it. For adoption and everything, we need to have these different representations of data. But all that set on the practical implementation, this is also what we see at Synera. So we had a customer who just rethought their process now with agents, and they were able to cover almost 95% of that process using either traditional automation, some LLM assisted tools, and so on. So that is a huge number, which is now possible, the net new coverage. We also had another multi-agent system that just communicated a lot more faster in terms of coordination and taking decision. And also when all that we need to do is update the design, make sure this is consistent to what I wanted to update, we see time to market also increases. So these were also some of our learnings from Synera that kind of overlaps and kind of confirms that the whole industry is feeling this practical use case application emerging, and we see a lot of success recipes that we can already start with. So that is what we learned at Synera, Daniel. So over to you now.
Thanks, Ram. Yeah, super excited to see what happened in just 12 months, right? So from probably in the beginning of 2025, when I asked the same question or make the web cup, the most companies that we had talked to, they said, yeah, for sure, we have AI agents, but it was normally a chatbot, right? Or something like for consume knowledge. And this is still mainstream what we see at the most customers. But I think Dirk and Ram, you made it perfectly clear already that chat is just the beginning. And now it's really about changing the way how we work by transferring tasks to autonomous agents and best case over different disciplines in a horizontal scale, as Dirk mentioned. And the technology is there. Since 2025, the technology is there and it's already used by customers. So we saw a very busy year where the technology evolved and also customers were so excited about the technology because the impact is not just a bit, it's an order of magnitude change that they adapted very fast. And we see the people that adapted very fast, they really have a benefit here already when you compare the business impacts. So super excited to see what just happened in this short amount of time. So to wrap it up, 2025, everyone was still a bit, okay, is the technology really evolving so fast? It seems yes. So the technology is there and we see it as customers. And what we also see, one thing is to deploy a system. That is still hard, right? But this is not the hardest part. The hardest part is to change the behavior of the people who are using the system. And only if you are able to achieve this, then you get your value. And the value that we all strive for in these companies are business impacts, right? So we want to be more productive. We want to be faster. We want to do more value added story with our engineers. So, and we see that these agentic systems shows and proved in 2025 that they can unlock this value. And what we see also that existing frameworks, like the V model that Dirk used as an example, they still are relevant, right? They get more enhanced. Probably, maybe next year we are talking not about software 3.0, but V model 2.0. Let's see. But yeah, it's interesting to see how this new technology is also now going more and more into the engineering domain. And this was just a look back, right? So, but it was so many topics. Now let's wrap it up and look into the future and see, okay, what will happen? And for that, as already teased, we thought about three bets. And handing over to Ram, who will let you know our first two bets, what we're thinking will happen in 2026.
Yeah, I should say this was one of the most exciting discussions we had in Synera, but also we did what is the bet because we are recording this now, so people will see it in 1 year. So we need to be very careful, but also
Oh,
very
you have to say,
excited.
mark my words, right? So to make sure. No,
Yeah,
kidding.
but very excited to see that we also see the trajectory. So the first one is we are going to see a shift in human AI collaboration. Um, And what we mean by that is, I think when a new technology pops up, there is always a question, what is it going to displace? But we feel with this paradigm of agent, we need more and more collaboration. And that is because if we look at the processes we have in the kind of engineering processes, they are designed to make sure there is review happening. They are designed to make sure there is confidence. And this is just a nature that we need to design processes that have a lot of human correction and outcome. And we also see this in automation. So we either need escalation path. So whenever this agent is not capable, we probably need a mechanism that the agent reaches out to an expert engineer and says, hey, I did it until now. Do you think I made a mistake here, or how should I proceed next? And the expert engineer now doesn't have to do the job anymore, but just leads or guides like how a junior engineer would ask. And also what we will see is more and more feedback loop. So we will use the learning from the corrections that human makes to maybe improve the output. And we will have this visibility, right? So we will see, okay, in a process, what are the steps that agents do? Where do they fail? how do we make sure the whole process is still debuggable and compliant? Now, what this means is every organization will have context that is unique to them. In our experience at Synera, no two companies doing a process similar. They're always having a different person to ask to, a different number they're asking. Some number is in some Excel sheet. So this is very unique to an organization. And that's why the system behavior will shift from not just prompts, but how do you guide this agent? And the way it's going to work is you build a graph or a multi-agent system. You make sure it's transparent enough that it asks the human, you earn the trust. We generate more and more of these context, and then we strengthen the agent, and then we expand the agent's capability. So we need systems that can show why it is making a decision, not just because I am this LLM, I can make this decision, but why in this specific context. And that is going to be very unique to, it's going to become a very important asset to every organization, how they engineer parts and how they do some certain decision. So that's the first bet. We will see more and more improvements. I think it started already, to be honest, the last few months in certain industries. So it's a bet that in our domain also it's going to happen more and more because our data types are even more tricky to talk about. So that's the first bet. And I will continue on with the second one now because it's very interlinked. And the second bet is a lot of improvement on spatial and geometrical foundation model. Again, this is not new, but we see how fast things are changing, especially last year. So we saw that the research around 3D model in different formats is accelerating a lot. And this is also what happened when the transformer architecture came. So there was a lot of research happening. People were trying to apply. And we see like giants like NVIDIA, they are really pushing hard to not just keep it at research level, but to derive technology and practical applications out of it. So there is a lot of research and let's say applications being derived on how can we enhance the text and 3D, especially for now in the mesh, but let's see how many data types can we cover. So how can we improve this understanding? So that is something that is already happening, and this happened last year. So the trajectory is increasing a lot. And I think what will this lead to is what we call physics-aware 3D model. So we already have this text to mesh model, and you can today go to it and ask it to maybe generate a 3D bracket for a Formula One car. It's going to generate something, but what you will see is it didn't consider the mechanical forces. It didn't consider the material properties. It didn't feel if the part is going to drop if I print it. And now we have a lot of improvements in making sure these models are physics aware, that when they generate an output, they are kind of able to reason, is this physical law obeyed? Is this going to make sense if I use this material for this laws that are going to act? So we will see that objects will have some realistic mass distribution. They will also be able to think about fracture patterns and so on. So, and then we will get the true first applications, maybe from some leading model providers in this area. So those would be my two bets. And now I pass it on to Dirk directly.
Thank you, Ram. Now coming up with the third bet, and I think that connects quite well to what you have showed, Ram. So our third bet, and we have discussed that extensively, I would say, in the last days with Daniel and Ram, is that product development processes will become more compilable. And what we mean by that, I think we can explain it perfectly with the comparison between software data and engineering data. So on the left, you can see the characteristics of software data. So software code is highly structured. It follows a standardized syntax based on the used programming language such as C or Python. it provides clear semantics and is fully compilable. So without changing anything on top of software code is ready for large language models, and you can just include it for training purposes in your LLM. On the other hand, you see on the right side is engineering data. And here we are dealing with many, many different data formats. Like we are dealing with CAD models, we are dealing with simulation models, but also with system architectures, which are not always directly machine readable. So here we are dealing with or semi-structured data. We have ambiguous syntax. There's a lot of domain-specific knowledge included in this data. And most commonly, the data is not or just partly compilable. And before we input or output engineering data, in our LLMs, it requires a lot of transformation, and we have to provide a lot more context in comparison to software data. But here we also see a shift coming up. So we are seeing there are a lot of, we call it text to X models coming up from startups as well as in the research community. So we are seeing text to cut models emerging. We are seeing text to simulations, and a lot of artifacts from the right side, so from the V model, especially from the product design and simulation domain, will be generated in the future by those text to X models. So for engineering, that means that we will have a code-based generation. So for example, when we're dealing with 3D CAD or simulation models, we will not generate the model itself in a 3D manner, but we will generate code in the first step, and this code is then converted into 3D models. Or what we else have as a opportunity here is to include parameterizations in the models. So the agents can modify parameters on top of the CAD or simulation models and not the 3D model itself. And I've also included some examples here where we see the shift to compilable engineering. For example, in system architecture, there was recently the release of SysML v2, where we have moved from a graphical modeling language now to a textual notation, which can be easily generated by large language model. But also we see a lot of compilable CAD and simulation models. There are Python libraries coming up, which are fully based on CAD code, or also some solutions from different startups where we see that this compilable code generation for engineering artifacts emerges. And this is a huge trend we currently see, and which will probably also evolve in 2026. And with that, back to you, Daniel.
Yeah, thanks, Dirk. So now you heard all our bets for 2026. And if you remember the formula from RAM, how you can determine the quality of the work of an agent, it was model, context, and tool, and you compare it to the bets we are just presenting, you will see that these agentic systems will be more and more capable in 2026 and will take more and more work that was not possible in 2025, but now in 2026 by having more context, especially to the AI human collaboration, bet number one. Then bet number two, that the models will be way more powerful as we see in 2025 because they get a new modality. After text, audio, and image, we will see that these models become more capable in geometry understanding, or how we call it here, spatial understanding. And what Dirk mentioned, if we're able to have the engineering knowledge and also the tools more compilable, that means also the tool layer can benefit from it, because then you can really create geometry or do bigger changes with the hands of these agents. So super excited to see what will happen in 2026. And I mean, we should already make a date here to have a meeting in December and see a recap if this really happened. But yeah, we learned one more thing, and we wanted to share this with you guys. Is one thing is that the technology is evolving, right? But this technology is evolving for sure, and you have seen it over the last couple of minutes. But there's one more thing needed to make it successful into your organization, and that is your organization itself. The whole agentic thing is not just one single tool that you apply and to make one person more productive. For sure, you have these use cases, but this is not the big thing that you can achieve with these systems. You heard it. The big music and the big business impact is when you do it horizontally, when you think about the whole product development processes. And for that, we see already companies that rethink their current structure of their organization. And I really like these figures that you see here in this slide from our partner Applied AI. They already thought a bit ahead and think, okay, how is an organization looking today versus how is an AI native, that would be the far right, looking maybe tomorrow or the day after tomorrow. And I think there's no right or wrong yet, but it's already good to think about, okay, when I can scale agents without any cost, more to say, how do I need to structure also my organization? Or, and I think this will be even more important for 2026, how can I support the change? How can I support the transformation? Because what we also see, and you saw it in 2025 recap, everything's happened so fast. And to be honest, humans are not very good when things changing so fast. So we have to make sure that we find an environment where we embrace this technology, but also give freedom to the engineers to adopt to it and also support them to think about how this new technology can really help them and how we can, at the end, build all better and greater products that we can all enjoy. So we're coming to the end of the let's call it slideshow. Let's quickly make a summary here. So 2026 will be the year where the agents go in production. So what does that mean? It means that production is not a demo in the C level or whatever, right? Production means these systems will be applied for sure, first in certain areas, but they will be applied and they will be used in a daily or weekly matter, whatever this job needs to be done from a time perspective, and they will generate massive value. And then what we see is that more and more companies are now starting. We always get the question, is it already too late to start? There are some blog articles about it. I would say it's not it's not too late to start, but there's also in this technology, if you start just 3 or 4 months ahead, you already have a huge advantage. So, and what we also learned, and I think Ram showed it very well and also was baked up by Dirk, is that we have to find the balance when to apply which technology. And also scout for processes that are able today and that will be able tomorrow, now with the new bets that we just presented. And as last but not least, it will only be successful in production if we create an environment where the organization and transformation is ready for it. And as mentioned, the change is very fast, so we have to make sure that we are supporting it from all different angles. So if you know of the question, okay, great, but how can I start or how can I get in contact with you guys? So we prepared 2 call to actions. So if you want to get more insights about the research that Dirk also presented in the recap of 2025, feel free to scan this QR code and get access to the whole case study about this research and also the possibility to get into contact with Dirk. And if you want to work on your own multi-agent systems in the future and to see how you can apply it in your engineering domain, more than happy also to get in contact to Synera here on the bottom. And now I think it's time to open the round. I mean, we have the experts here in the panel. So let's go into our Q&A session and let me check if we already get some questions. And let's see. Oh, there were some first bets already. What is it? So the first was already a human mass interaction in the workplace. So that is maybe the first question. So one thing, Ram, you mentioned the first bet will be more AI and human collaboration. But the question is, what do you think? Where will the collaboration happen? Right? Will it be, I don't know, in the browser or in the chat or
Yeah.
whatever?
Yeah. I think what we see is two ways of this collaboration. Agent doing most of the job and going to human for a review, or human doing most of the job and they give it to agent for some repetitive task. And these are two different environments, right? So if it's a agent doing a job and then reaching out to human, we need to have a place where humans are working with other humans a lot. So maybe it could be a communication channel, one of our more commonly used communication channel, or maybe a chat interface because it's very easy to type a text message or something there. But the second one is interesting, that human does most of the job and then the agent is asked to do the rest of it. Maybe this will happen inside our CAD systems. Maybe you're working alongside with the geometry, uh, and then you say, okay, this is for me, please use our standards for rib creation, and I want the surface to be a rib. And probably you will have an interface where the agent could then start off a process, take that surface, do rib optimization, and come back here. Here's what I found. So probably I think we will see these two kind of interfaces happening. The first one may be happening faster, where the human is asked to give review. Maybe the integration in the CAD systems or the systems we use, maybe it comes once we find some robust ways to do this. That's my way to look at things.
Gotcha. I think it was also a good icebreaker question because now all the question pops up. We have 7 minutes left, so I need some short, compact answers from these experts here. So I shoot the next one to Dirk. So the question is, uh, when can we see models, so large language models probably, that can read 3D models and interpret it, find faults, or do even improvements? What do you think?
I think we will see it in the future, maybe already in 2026, because I think 3D models or 3D data is nothing else than just normal data. So we always have to keep in mind how data is processed within LLMs. So basically, it's all converted to numbers, and then it's processed in the LLM. And we have found ways to deal with images, to deal with text by always converting it first to numbers. And I think this is also feasible for 3D models. And if we have a lot of training data and then can incorporate 3D models and train LLMs based on this type of models, then I think we will see it in the future very, very soon.
Gotcha. I would also agree that probably understanding geometry and reading it will be easier than writing it. But this is the second
Yeah.
question. And Ram, over to you. Is it possible to write geometry directly in exchange formats like STEP?
We tried this internally. So I mean, step is a text file, right? So you could even in Synera, you have this possibility to import like step file as a text, and you see if it can do this. Like you mentioned, Daniel, I think there are really we see this happening now with, for example, the latest model, for example, 5.2 and this Sonnet models from Claude, and also Gemini. Exactly. I think Ryan is in the chat, so he probably knows the best. But we see this happening that more and more of this is becoming possible. The complex ones definitely are tricky. So it's not possible to take a additive manufacture bracket AM and ask it to find the exact spot where there is probably an unwanted protrusion. So this is not possible. But if you want to already experiment with text-based exchange format, I think it's really solid in understanding, at least for some context. Okay, this is what I mean, and this is what it means. And you should also check out what NVIDIA is doing here. They are really pushing the limits. So it's happening. I think the change is there, happening there.
That is also what we see in text to cut, right? It's probably more like you create a macro that is able to generate the geometry. Either it writes it in step or in Synera or in other technologies, like for example, Zoo. Or I think last time Dirk, you
Yeah,
also mentioned, what was it? Query cut, like another technology to where you can do geometry operation in text.
Exactly.
yeah.
Okay, next one to Dirk. Can you say more about foundation models for computer-aided engineering and who are some early leaders you are seeing? Any connectors in the works? So probably the connector question I sent to Ram, but maybe you first, Dirk. Do you see any foundation models?
I think one very advanced startup is Zoo. I also checked their website today because they are basically doing what we've described. They are generating cut source code for geometry creation and manipulation. And this, I would say, is one foundation model that is very advanced. And I recommend to check out their website and their use cases because they are quite impressive.
Ram, anything to add?
No, I think maybe that is also what, as an ecosystem, we have to kind of let's say agree. So I think step was an exchange format, right? So it's a more legacy now. I'm also very curious how we all as people in this ecosystem kind of agree, hey, let's expose our cat parts like this.
Now, also the
That's
foundation models, right? So I think
yeah,
the question
yeah,
was also, do you see any players popping up in the foundation model space already? And how do we connect to them?
yeah, yeah. I think I'm a bit fan of NVIDIA's work just because of their research group. I definitely see this becoming a foundation model provider.
And what we see is, and maybe we should make a whole webinar about it. I think also 2025 was the year of a lot of new companies, right? So we saw a lot of companies popping up in vertical agents, but also in the foundation space, right? So EGI or PhysicX. So there are more and more companies playing in this round. But yeah, maybe a good one, Ryan, for our next one, next webinar. Oh, I have one here which goes into enterprise. I know we have a lot of enterprise yeah, visitors here for the webinar as well. So one, maybe Ram first, reality check from an OEM. We have air-gapped IT systems, so no internet, very limited GPU and strict cloud controls. Given that,
Yeah,
how do you see this working in practice when you can't rely on big foundation models or elastic compute?
yeah, perfectly. Kind of also the discussions we have at Synera. Today, I was at a call with a customer, and they kind of said the same requirement, and therefore the question is, what is do we always need a large language model? So maybe let's break down the question. One question is the data, right? The data, the intelligence layer. Do we always need a large language model? Maybe that would change with these small language models that are coming in, or even this vision language model. So probably they are self-hostable. But I think what Dure Rasa says is also very important. The second part, which is in general, in our domain, we have this enterprise security and needs. And I think one of the implementation point we didn't mention was success was found when we don't try to reinvent the whole process. So we shouldn't probably change the entire existing IT stack to fit this new AI model, but rather find patterns or architecture where we can make sure this orchestration becomes faster. That's why what we do is we see more and more hyperscalers being more closely involved. We see a lot of improvements, also partnership between these hyperscaler and foundation model. So everybody is working towards this data retention or zero data retention, and make sure compute is not anymore a blocker. Um, but you're absolutely right. So this is a strong requirement. At least we have in Synera a philosophy to always make sure these principles are kept in mind while designing any solution. And that would be a short answer.
And we're also working with a lot of OEMs that already find or found a solution, right? So especially the hyperscalers, they have, let's call it, options to make these scenarios that you described somehow possible. And yeah, we are more than happy to also facilitate meetings with them. Okay, we have more questions here. We are running out of time, and I really want to value the time here from all the audience and also from my experts here in the room. So what we will do is we will answer all of these questions later, and we'll send out mails to the people who raise these questions to make sure that we all cover them. I want to say thank you so much, Dirk. Also, thank you so much, Ram. It was a pleasure. The hour was like flying away, so I thought we are just talking 5 minutes, but when I look on the watch, it's already an hour. I saw that a lot of the people stayed until the end. This is always a good signal that you guys did a phenomenal and perfect job here. So yeah, super thrilled to have you here, and hopefully we make a second session at the end of the year to see um, who was right.
I
Thanks.
hope the
Totally.
customer is always right. Yeah. Thanks so much. Bye.